Hi folks, it's Bob McKenzie here. Welcome back to my Fulton woodworking shop. In this video I'm going to show you how I assembled a small side table that's about 16 inches square, stands about 27 inches tall, has a single pull-out drawer and a bottom shelf. I actually built two tables. This one here out of rough hickory was my prototype. I used breadboard type construction for the top and the shelves, and this was my final product made out of local silver maple. As you can see, I made some changes in the leg design. Here you can see the difference in the construction type of the top, very similar to that of the shelf below. The one on the right is the true breadboard construction where it's glued in the center and pinned on the ends. I went ahead and just glued the breadboard on the final product. We'll see how that holds out over time. I chamfered the edges of the tops and the shelves on both tables. I tapered the legs of the prototype, but decided not to do that on the final table that I built. The final product won second place in its class at the 2019 Iowa State Fair contest. I'll be bouncing back and forth between the two constructions. I will keep you appraised of the lessons learned on the first table as I construct the second table. So with that little introduction, let's get out to the shop and get started. I seem to always start these projects with the legs. On both tables, the legs finished product are 1 3/8 by 1 3/8 square by 25 inches long. I seem to never buy material thick enough to make the legs straight out. I use 3/4 inch material glued together. After glue up, I run one of the edges of the glued up leg through the jointer to make sure I get a good perpendicular angle at one corner. I do final sizing at the planer. I pay particular attention to making sure I take the same amount of material off of each face so that should the seam be visible in the final product, it will be in the center. I set the legs aside and went and glued up the top for the first table. I used 4 3/4 inch members. I glued these together using biscuits. The final dimensions of the top were 16 3/4 inch square with a 1 inch overhang from the sides of the table. The apron for the prototype table, which I'm working on here, was cut such that I would enhance the selection of the grain all the way around. Where the final table, I used a continuous board which gave me a grain match all the way around. After marking the rough lumber for the apron, I went over, cut it in half, and then took it to the planer to size it accordingly. Once I went through the thickness planer, I took it back to the table saw, cut the pieces into rough dimensions, and then over to the jointer where I was able to get a good perpendicular edge. After getting a perpendicular edge at the jointer, I went back to the table saw and cut the apron pieces down to width. Again, this was a pick and choose of grain, so I was cutting a little bit off of each edge until I got to a final dimension of 6 inches. Once I got the apron pieces down to thickness and width, I then went and cut them to proper length. The apron show is 12 inches, so I need to add enough for 2 tenons. In this case, I had 3/4 inch tenons on each end, so I was going for 13.5 inch overall length. Like most, I cut the mortise first and then sneak up on the thickness of the tenon. Here I am laying out the mortise location on the leg. I use a mortising chisel and bit, so I usually lay out just the center line of the mortise. The tenon is 1/4 inch wide, 4 inches long, and 3/4 inch deep. I always like to have plenty of play. I make the width very tight, but the length I give myself 1/8 inch top and bottom and 1/8 inch in depth to make sure I've got plenty of room to slide the tenon in. I built the bottom shelves just like I did the top. They're put together with biscuits Finished dimension is 15 inches by 15 inches square. The prototype table had tapered legs. Here I am setting up the taper. You line up where you want the taper to begin, and then you draw a line on the table saw so that you can line up the line on the end point on the leg. Then it's just a matter of cutting the waste away. I make this simple and only cut 2 faces of each leg. Instead of tapering the legs on the final table, I instead put 2 recessed tapered flutes on the outside surfaces. To do this, I used a 3/4 inch bowl and tray router bit with a top bearing. I built a special purpose jig for this bit to follow. On the bottom or back side of the jig, I positioned cleats fore and aft and top and bottom to secure the leg from moving using CA glue. To achieve the taper of the flute, I installed an 1/8 inch spacer at the bottom end of the leg jig. As you can see, once the leg stock is installed, it now sits at a slight angle to the jig. I use 2 of the legs as support for the jig. As you can see, there's an 1/8 inch gap at the end because of the recess of the leg in which I'm cutting. And here I am making the fluted cut. I start at the bottom where the flute exits the leg and is flush. As I work towards what is the top of the legs, you can see the chips fly where the flute is cut about 1/8 of an inch deep. I make a pass up and a pass down, and because of the flat bottom bit, I end up with a flat bottom flute with rounded contoured edges. Now that the legs and top and shelf are done, I'm putting the tenons on the apron pieces. I find using the dado blade to cut tenons works just fine. I usually set it up so that I'm making 2 or 3 passes. That way I can use the fence without having to put a temporary fence on to bury the dado blade. After the tenons are cut, there are several ways to trim them to fit the mortise. I go back to the dado blade and the table saw. Without moving the fence, and after I adjust to proper height of the blade, I then go back and turn the aprons on edge and cut the tenons to the right width. As I'd indicated earlier, one of the apron pieces actually becomes the door front. Here I am separating the door front from what I'll call the 2 shoulders. Here's how it'll go together in the final scheme of things. Here's a lesson learned. On the prototype table, I made the aprons all the same length, figuring that if I used a thin kerf blade to cut the door front out, I'd end up with about a 1/16 of an inch gap in between each edge. I found this gap to be too great. As a result, on my second table, I made the apron piece that was going to be the door front a little bit longer, the thickness of the blade, figuring that I could split the difference between each side. I believe that it is still too much of a gap, and if I'd had to do this again, I would give myself plenty of room and then trim the door front to get the gap I like. Let's turn our attention to the breadboard construction for the top and the shelf. Here I am putting the mortise in the breadboard end slats. I turn the board over and run it through twice using a 1/4 inch router bit. Here I am cutting the tenons on the tabletop. Again, I'm using several passes through the dado blade to get the appropriate depth of the tenon. To trim the ends of the tenon, I go back to the saw, raising the blade but maintaining the fence in the same position. This does give you somewhat of a sloped tenon end, but in this instance I don't think that's going to matter much. You can see the tight fit I got with the breadboard, and I keep the breadboards long so that you can take them off without damaging the seam or the joint between the breadboard and the top. After locating the holes in the breadboard and on the tenon, I elongate the tenon holes so that it will allow for the expansion. As I stated earlier, the assembly is to glue in the center of the breadboard to hold it tight, and then in my case I clamped it together and drove the pegs home. Cutting off the extended breadboard pieces is simply a matter of putting in a spacer between the saw blade and the fence at the table saw. As I mentioned at the outset of the video, I went with more of a traditional tenon and mortise construction on the second table. In this case, the tenon is merely 3/8 of an inch deep. Glue up of the table frame went in stages. I glued the two sides together, and then I glued the back on using a spacer to make sure I got a square tabletop. Prior to the glue up, I went to the router table and put a 1/4 inch groove along the top of the apron pieces. This is so that I could put a self-made bracket in to secure the top that would allow it to expand. I then installed the drawer shoulders. I'm using a Bloom undermount slides for the drawer. These need to be mounted to an internal support. The drawer shoulder pieces extend out 3/4 of an inch. This will allow a flush connection between the drawer slide support and the front of the shoulder. The shelf support is a small triangular shaped stub that is held into the leg with a mortise and tenon connection, just glued. To build the supports, I started out with the test material I used to dial in the dado blade for the tenons on the apron. After ripping this to proper width, I took to the drill press and put a counterbore in. I then put an oversized through hole in for the screw to allow for expansion of the shelf. I then clean up the tenon to proper width. I separate the shelf support from the working stock, and finally I put the 45-degree taper on for the final dimension. The shelf rests on the supports, and the corners have to be notched so that it will nest in with the legs. I cut this notch at the bandsaw using the fence, and I set up a stop so that I can duplicate the notch on all 4 corners. I then head over to the router table and put on a small chamfer on the top and the bottom of the shelf to mimic that of the greater chamfer on the top of the table. For the drawer construction on both tables, I used dovetails. The visible drawer front is attached to the drawer box at the final stages of construction. I use a lead jig to make my dovetails. Here I am, I've got the front and back members, the 2 side members, and plenty of practice materials as well as the instruction manual. I'm not going to spend a lot of time on the setup of the dovetail jig to build these boxes. I have been asked in the past to do a special video on those, which I will do in a later date. Here's the finished box. I'm using 12-inch slides, so the box is 12 inches deep, outside to outside. There's a certain envelope of dimensions which must be adhered to for the width of the box. And there's a modification to the back of the box that must be made so that the slides will be functional in all their adjustments. In lieu of cutting the notch in the back, I went ahead and shortened the back completely. This allowed not only for the brackets to be installed, but also to slide the bottom in. Assembly of the drawer box was pretty straightforward. I put tape on the inside of the joint to keep from getting glue squeeze out inside where I couldn't clean it up. I opted not to put any drawer pull hardware on this and simply rounded a handhold on the bottom edge of the drawer front. For assembly, I used Craig self-tapping screws. Note the access between the drawer slide support and the apron. For the attachment of the shelf, I centered it in the upright position and then clamped it in place, flipping it over to install the Craig self-tapping screws. I found that I needed to put a pilot hole in because of the hard hickory. I also used soft soap as a lubricant. And finally, the finish, I used BioShield Hard Oil number 9, which is really oil for flooring, recommended for moist, wet areas like kitchens and bathrooms. So there you go, folks. That's the story of how I ended up with 2 identical tables made out of 2 different wood species. I like the idea of building prototypes for all my projects. I don't like building it out of a inexpensive wood species that doesn't look good enough to keep. I found this rough hickory in a reduced cost pile and decided to use that. Thanks for watching, and if you've got any questions, leave them in the comments section, and please don't forget to subscribe. Happy woodworking!